All right. Hi guys, Townsend here. I've got the challenge problems. So these are the bonus ones. These are the challenge ones. Now, if you guys did these, good job. If you did not and you want to try to do them with me, please do so. I don't know which page these are on, but I do have 4 of them. So just try to find this one with the train. Okay, this is challenge problem with the train. It says at Union Station, you notice that 3 trains just arrived at the same time. All right. So I'm writing down, I'm underlining exactly what they tell me. I have one train, we'll call it train A. I have another train that's train B. I have another train that's train C. Okay. Let's see what they give us, what information they give us. Okay. Train A arrives every 10 minutes. So here's train A. Every 10 minutes, this train arrives. So knowing that, I have 10 minutes, and the next 10 minutes is going to be 20 minutes, and the next one's going to be 30 minutes, and the next one's going to be 40, and then 50, and then so on and so on, because it's every 10 minutes. Okay. Train B arrives every 12 minutes. All right, well, then train B here is going to arrive at 12 minutes, 24 minutes, 36, 48, and then 60. Okay. And then train C arrives every 15 minutes. So that's 15, 30, 45, and then 60. Okay. All right. And then the question I want to know is how long must you wait until all 3 lines arrive at the station at the same time? Well, think these are minutes, right? So it's 10 minutes, 12 minutes, and then 15 minutes intervals of the train arriving. And if they want to know what time that you're going to see all these trains together, you would want to look at when they would all meet at the station at the same time. And they're going to meet at the station at the same time at that 60-minute mark, okay? Because until then, they're at different times. So that's the only thing that you guys want to think about is like when you would see them together. And so they end up being together at this point at 60 minutes. Okay. All right. So that's challenge problem number 1. Okay. Here's challenge problem number 2. Kristen's car goes 18.95 miles for every gallon of gas. So it's for every 1 gallon. So when they say every, that's every 1 gallon of gas. Okay. If she's planning a trip for 379 miles and gas costs $1.23 per gallon per 1 gallon, what is the cost of gas for the trip? Well, this is one of those real life questions because if you have to budget out your money for vacation, you want to make sure that you have enough money set aside for gas. Okay. So all I'm doing right now is writing down what they tell me. The information that they give me is this: 18.95 miles for 1 gallon. Okay, and I just write that as a ratio. This is all they're telling me right now. 18.95 miles per gallon, and I just set it up like a fraction. Okay, and I'm going to set it equal or equivalent to what they tell me her trip needs to go to. So it's 379 miles. Okay, 379 miles, and I need to figure out how many gallons of gas this will be. All right. And as long as you take your units, which are miles, and you keep them at that same level, at that top level, you can always set up an equivalent ratio. Okay. And now I have 18.95 over 1 equals 379 over something. This is like your unknown, like your x value. All right. So go ahead and get out your calculators, and you want to cross multiply divide because anytime you do that with fractions, it'll give you this answer right here. Okay. So start with what you have. You can't cross multiply this way because there's nothing there. So you have to do this. So 1 times 379, of course, is 379. Then divided by 18.95 equals 20. All right. So 379 miles requires 20 gallons of gas. 20 gallons of gas. Well, now they need to figure out how many or how much that will cost. Well, if you know it's $1.23 per 1 gallon and you need 20 of those, you just want to multiply 20 times $1.23 and you get $24.6, which in math that's 6 zeros because you have 6 tens, so that's 6D. Okay, so she's going to need $24.60 for gas, which isn't too bad, right? That's pretty cheap for gas. Gas is like $1.70 right now, so that's pretty cheap. So she just needs to set aside $24.60. So that's not bad. Okay. All right, next one. All right. Here we go. This one here, challenge number 3. Donnie has $5.10 in nickels, dimes, and quarters. He has an equal number of dimes and nickels, with the value of the quarters being $2.40 more than the total value of the dimes and nickels. How many dimes does he have? This is what I got. So he has $5.10. You're going to need 9 nickels that are 45 cents, 9 dimes that are 90 cents, and then 15 quarters, which equal $3.75. All right, so it should be $2.40 more. So that one was tough. I'm not sure how you guys set it up. There's many different ways. I drew a picture for mine, but you can set up a equation too. All right. All right, that's that one. And then here's the last challenge problem. Let's see here. Jay can paint a car in 6 hours. Mike can paint the same car in 3 hours. All right, so I have here Jay can paint a car in 6 hours. Mike can paint a car in 3 hours. If they do it together, so if they work together, how long will it take them to paint a car? Well, I'll take a couple answers for this, because depending on their speed of how fast they work when they work together, I'll take half as well. So like if you're going to say 2 for this, I'll take 2 hours. There's another way to do it too. If you want to think about it like in a ratio, you can do this. You can say 1 car for 6 hours. You can set it up like a fraction. 1 car for 6 hours plus 1 car for 3 hours. Okay, and so this is what Jay does, and this is what Mike does. Okay, Jay does 1 car for 6 hours, and then Mike does 1 car for 3 hours. And if they're working together, I went ahead and I just added this. All right. And so when I add these fractions, I need to make sure the ratios though. But when you add these, you have to have a common denominator. So this would be 2 to 6. So instead of 1 to 3, I increased it to 2 to 6. So therefore, I can compare these and make these the same, because I have to have the same common denominator. Then when I add my numerators, 1 plus 2, I get 3. And then 6 stays the same. So I have 3, 6, which is 1 over 2, which means 1 car, okay, in 2 hours. 1 car, and it takes them 2 hours, okay? So that's what I came up with. I believe that to be true. If I took anything else in class, because we talked about the speed of anything and how fast they work, I'll take that too. I feel like there's a logic issue to this. So any questions or any concerns with that one, please let me know. But as far as this one's concerned, I'm saying 1 car for 2 hours. Okay? Hope you guys have a good day. See ya. Bye.